Hey guys, this is another video on the Neo4j practice. So we're going to write down more queries. I'm still using the Stackoverflow database, which we used in the previous video. If you haven't seen it, please check out the previous video first. So we're going to straight away go into it. So let's write the query, which will be, let's find the tags that get the highest answer percentage. In the previous video, we found we used this relation. Let me just, yep, this relation to get the highest answered questions, right? And also we found just all the questions with their tags, but now let's find basically the percentage, right, of all the answered questions to the entire questions. So as you might have guessed, so let's write the quick plan what we're going to do. So we need to find all questions, then through relations, right, traversing from answered to question to tag, we can find all answered questions, right? And then basically we need to just group by tag name and divide answered questions by all the questions. However, there will be some problems. All right, so since we wrote this query, I'm just going to copy paste some Cypher to speed up the process. So this is all the questions we have. So we are going from question to tags, right? And we're getting all the questions we have with their relevant tags. Like in the previous video, we can return tag.name and count all q, and we're gonna get as all q count. All right, and let's order by all q count descending, and oh my god, limit, if I can spell it. All right, limit to 5. All right, so we did this before, right? So now we're gonna do the same, but for the answered questions. The only problem is that we need to somehow to combine the queries. So if I'm gonna comment this out, I'm just gonna copy it, paste it here, but the top part will be a bit different, right? We're gonna go through answered relations, so we're getting only the questions that have that got the answers, meaning we're getting the count of all answered questions. So here I'm going to replace all q with answered q, and we don't need the a even, and we can order by answered questions and descending, and we're getting the results, right? The results are different, less questions. So now we need to combine those two in one query somehow. So if I'm going to just add this in here, the query will break because as you can see, this is definitely not the result which we supposed to get, right? When we are counting all the questions. The problem is that we are matching everything once again, and we are basically, as you can see, creating like a loop, a huge loop, like multiplying the results. Yeah, tremendously. So we're getting the incorrect results. So how can we? This happens because we are taking this all q into this query down bottom, right? And we need to somehow just to take what we are returning from this statement, just basically these values we need to get into this query. So we can do this using the with clause. So we're just going to take the tag and count all q as all q count, right? And we're not going to take the all questions down to this query. And in here, we will reuse the same tags since we found them already. So these are all the tags we found entirely in our database, right? So we don't need to search for the tags once again. We can just move them here and just isolate basically the tags that got the answers, right? However, we need to find all the answered questions by traversing the relation. All right. So now in this query, we are getting by the seventh line, we have only all the tags, the count, and now we have all answered questions. And now we can do the same thing like we did in here. We can just take this bit and paste it in here. See, I think we can just return everything straight away, but let me just use the with statement once again. So we will get the, we will take the tag, we will take the all queue. We need to specify basically all the values we want like to carry down to the next line of the query. So we are not taking the answered queue, we are just taking the count, right? So we're getting, instead of numerous rows, just one row. All right, and here after with clause, we can also just, we can straight away return the answer. Let's take a look at that. All right, and we can just take answered queue multiplied by 100, and we can divide it by all count as answered percentage. And we can order by answer percentage, and let's get the result by 10, and let's see the result. All right, so we're getting 300% answer. So some questions got more answers that than than the question itself. All right, but nevertheless, I mean some tags, but there is a problem with that because some counts, they are very low, so we just we can add additional filter to make sure that the answer count is like at least above 50, because here it can be like 3 answers and 1 question, right? It can be very small. Let's take something bigger which is more popular. And oh, not the with, where. So the cool part of with clause, we can use a where after it, right? So we can, as you can see, we got the query, right? We didn't have the count in here in this line on the line 7, but then using with clause, we can, for example, get the count or do some other aggregation function, right? And in the next where clause, right after the with, we can use where clause and yeah, filter out more results through by after we applied aggregation or maybe some other queries, right? So we are filtering out answer count, which is above 50, and yeah, we're getting different results. So we're getting database, which get 101%, and yeah, and Cypher 99, 97, and etc. And let's actually check out how many questions is there. So we can just change the return statement. I'm gonna comment this out. Let's just return tag name, answered count, and the all question count, right? And yeah, let's order by all count. All right, so this is a bit different result. So the database was here, right? It's got 53 and 52. As you can see, this is a very small sample. That's why it got 101%. So Neo4j is more popular, but the answer percentage is smaller because the sample is bigger. But nevertheless, as you can see, yeah, we're getting the correct results. And pretty much all the most popular questions, all the most popular tags, they're getting less answers than the questions themselves. All right, let's move on to the next query. All right, let's do one more on aggregation, but just a little bit different. So let's find users who provided highest total viewed answers. All right, might be a bit confusing, but let me just explain it one more time. So here is our schema once again. So we need to find the users, right, who provided the highest viewed answers. So obviously, we need to find the questions, right? Because the question contains, if you recall from the previous video, it contains the property view count. So we need to traverse from user to provide it, from user to answers, and from answers to questions. And in the questions, we need to access the view count property. And basically, for every user, we need to sum the view count, right? And then we can group by user and yeah, do the regular stuff we did before. All right, so let me just write it down. So the first thing we're gonna do, we need to get all answered questions for each user. And the second one, we need to sum all questions view count, right? And the third part, basically, we need to once again group by user's name and yep, and return the view, the total view count. All right, let's see how we can do that. So the traversal part we already done many times. So I'm just going to copy paste it here to speed up the process. So we are just jumping from user to answers to questions, right? Through using our relations. Nothing new here. So we're going this path to questions. And let me just return every single one of those. So you have the idea. Let me return the answer and the question, and I'm gonna limit this to 25 so you get the view of what we are doing. All right, so this is pretty much the graph we will have. Let me just add display name here, and on the answer we'll get the title, and on the question we'll have the title as well. All right, so something like this. Let me zoom it a bit. So we have, for example, Thomas, who provided answer, who has a question. And here we have on the question view count. So we need to summarize the view count for all the questions he provided. Right, let's do this. All right, I'm going to remove the answered here. And yeah, let's continue with the query. So we're going to use the with clause. So we're going to take the user. We're going to count all the questions straight away. How many? Let's use the count, right? So how many questions was in total? So this will be question count. So this is something we did before. And now we need to summarize. So every user will get numerous questions, right? So this is like one-to-many relation. As you can see, this user, right, he has one question, sorry, the answer, answer, answer. So each user has numerous answers and obviously numerous questions, right? So we need to aggregate all of those somehow. And here we're going to use the new function called reduce. If you work with any programming language, probably you know about this. And here let's do something like total views equals 0. So the syntax is of the reduce. In the beginning, we specify our accumulator. Then we specify what we are going to loop over. So here I'm going to use something like n in and in what we are looping in. So this is gonna be our like current value, and here I'm gonna collect the queue. So we're gonna aggregate all the questions into list, and we're gonna loop over this list, right? So here we're getting just a single question every time on every iteration of this Cypher pattern, and here we're collecting all of those and looping over them. All right, and by dividing this by this vertical line, uh, we specify what we would like to do. So we will uh, increment total views by n view count. Let me just change the n to, I will write like single question, right? And this will be single question view count. All right, and now we can specify the alias, something like um, uh, question total views. All right. And now pretty much we can return them. Let me just add additional filter where the count of the question at least above 5, so we don't get a very small results. And now let's return everything. Nothing new here. We will return u display name. So user's name, right? If I get it correctly. Sorry, user, yes, display name. Then we will return count and question total views. And once again, let's order by question total views. This will be descending, and let's limit to 10. Let's see the results. And I made a mistake somewhere. Yeah, question count, obviously. All right. So this is the result. We're getting the user CyberSam who asked, well, he participated in 211, he answered 211 questions, and question total view count is 19,000. Wow, that's huge. All right, nevertheless, so let's review what we did. So once again, we matched all the users, found all the answered questions they have, and then we did what we did previously, right? We took the user, we counted all the answered questions, and then we summarized the results. We used the reduce function. So in the first argument, we specify our accumulator, then we are mapping over we're specifying basically the our current value and what we are mapping over using the in clause, and we need to collect all the questions to convert them into a list. And then we're just basically after this vertical line, we are specifying what we would like to do with inside with basically the function, what our reduce will do, right? So we're getting total views and we are incrementing them by view count. So we are starting from 0, and every time we are looping over this list, we are adding view count. All right, so if you work with JavaScript reduce or Python, whatever, probably you know this function, but just wanted to go over it. And I work with some large data sets, not like tremendously high, like billions, but every time it was faster inside of Cypher query than in JavaScript. So we use reduce quite often as well here. And one other thing, for example, what we can do here, we can, just to mention, we can also add additional, we can filter out by tags, right? So here we have tags, which is an additional filter for our questions. We can add, for example, tags like so, and then what we did before, like we can add a tag name, which is in some specific topic. We know that there is like Neo4j and for example Cypher, and then we can use these tags right in our query and then return, for example, collected tag name, something like this, right? So now we're getting the same one, but we can see how often he replies to each tag. The results didn't change much, so he is answering probably all the questions he participated was, let me change this to database. Maybe there is an error in my query. Let's see if the results will change. Yeah, for a second I thought there is something wrong. Yes, so all the answers he gave were from Neo4j database. So yeah, like so we can filter out, for example, questions by tag, right? I showed in the previous video how we can use the where clause to do that. There are several options, and yeah, we can collect the tags and see all the tags he answered. All right. I think this will be it for this video. In the next one, we're going to move to the interesting topic. I like it, where we're going to see the correlation between different nodes. So we're going to check how often different users bump into each other when they're asking, for example, questions, right? So how often, for example, CyberSam and Thomas Bratanich run into each other when they're asking questions in the comments or any other way. All right, thanks for watching this one. See you in the next one. Take care. Bye bye.